Gotta say we're multiplying rational expressions. Multiplying rational expressions. What's that word rational mean when I say it in this class? Right. It's the worst thing you could ever see on a test. You know if you see these, you're screwed. Yeah, fractions. Yep. Yep. So funny, everybody thinks the same way. Yeah, don't worry, you're not alone. Everybody hates fractions. Let's talk about, all we're doing today is multiplying fractions. If you were in normal algebra class, we'd be using just numbers, but you're in Algebra 2 Trig, so we're going to use polynomials, and you can see what you're in for from the sheet that I passed out. Let's practice with normal fractions. Suppose I have a half times 3/5. What do you get? Yeah. When you multiply fractions, you multiply the top times the top and the bottom times the bottom. If you want to do it, you can do like this. Nope, not for multiplying and not for dividing. Common denominators are only used when you're trying to add or subtract, which is why we're going to study multiplying and dividing first, because they're the easiest. Top times top, bottom times bottom. Always. You got to remember that. Okay, it's going to get confusing, so you got to keep track of that in your mind. Multiplication and division with fractions is really easy. Let's play again, though. Let's play again. Suppose I have a half, and I'm going to multiply it by 6/10. Right? That's true. You can multiply top times top, bottom times bottom first. But there's something else that sometimes mathematicians do. And we're going to practice it today because we're going to get polynomials. We're just going to factor this. Factor it. We're going to break it up. We're going to deconstruct 6. Give me two things that multiply to be 6. Factor 6 for me. 2 and 3. Instead of representing it like that, I want to do it like this. 2 and 3. How about 10? Okay. And here's the rule. Here's the rule. You are allowed to cross off, to reduce, to cancel. All those things mean the same thing. Things that match in the top with things that match in the bottom. But you can only cross off 1 for 1. You know what I mean? Yeah, 1 for 1. Like if there's 1 on the top and there's 3, if there's 1 2 on the top and 3 2s on the bottom, you can't cross them all off. 1 for 1. 1 for 1, that's it. So watch. Boom, boom. And then so what you can do is you can reduce the fractions down. 1 times 3 is 3. 5 times 2 is 10. And we get the same answer I showed you how to reduce. Whatever you want. Whatever you want. I'm going to warn you, though. At this point in time in your math career, first of all, you are in the highest level Regents math class offered in the entire state of New York. Okay? Yeah. To only memorize one particular root and to say, I'm only going to do it this way, it's okay, but you might get stuck. All right, let's get more onto this class. That was like middle school, 9th grade. Let's do stuff from here now. We're going to practice. What's the matter? Oh, you thought that was this class? Suppose now we're going to throw some variables in there. 4a, 9b times 6c over 3d. There's different ways that you could do it. You could cross things off right off the bat that you think match up, or you could multiply and then reduce. For me personally, for this kind of problem, I see the answer as multiplying and reducing as easier. Top times top, that's going to be 24ac divided by 27BD. And you can take a sneaky route now, sneaky route. If you do have your calculator, break it out. I'm going to show you how to reduce fractions in your calculator. All right, all right. Good little conversation we had. Okay, okay. Come back, come back, come back. So you want to reduce that, right? And you're like, damn, I don't know. I forgot how to. You know how to do this, Carly? How do we do it? What do you do? Watch. No, even easier than that. You're right. Don't get me wrong. You're right. You're dead on. Very few people would think like that, Carly, because you're so smart. I'm talking about for the person that hates fractions, can't reduce them. Watch. 24 divided by 27. Enter. Math. Convert to a fraction, and your calculator will reduce the fractions for you always. It's foolproof. You will never mess that up. Okay, let's play. Yeah, watch. 24 divided by 27. Enter. Math. Convert to a fraction so that the answer is, of course, 8AC over 9BD. Now, here's the other way that you could think of it if you didn't use your calculator. Carly, tell me now. What goes into both these numbers?
I did 24 divided by 3.
Yep. Yep. Because 24 is really just 3 times 8. And, yep. Sure. And you just get 8/9. That's where it comes from. And that's really what your calculator is doing. You know what I'm saying? So this one, don't multiply the tops times the tops and the bottom times the bottoms first. You will get a ridiculously long, crazy looking thing. So Sean, you also cannot do the following. The only time that you are allowed to just cancel stuff out is if it's directly linked by multiplication. Directly linked by multiplication. If you see an addition or or subtraction symbol in between stuff, you cannot cross it out. Yes. Yes. Yeah, so this is the single most common mistake. Don't ever do this ever. Ever, ever, ever. You immediately receive a 0. No, the rest of your problem will not be graded. People do this. People do that because they memorize that rule, that stuff in the top, and then they do this. Yeah. It's just making up stuff. Don't do that. Never, ever, 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 ever in your lifetimes ever do that. There you go. Okay? Do you want to see the reason why you cannot do that? Or you're okay with it? What? Very nice. So here's what you do. Step 1 is you have to factor everything. Everything. It's like 4 problems in 1. So let's factor the top one. Let's factor the top one, right? Do you want to rewrite it, or do you want me to just put the factors on top of them? Okay. So x squared minus 4x minus 12. Give me 2 numbers that multiply to be 12, negative 12, but add to be negative 4. Okay, so this is negative 6, negative 2. That's this one right here. I'll put them in color so you can see them. Okay, that's that one, so you can understand. Now let's do the bottom one. Oh, I made a mistake. Sorry about that. Sorry, in my rush to move on. Now we're going to do the bottom one in green, right? X squared minus 4, that's the difference of 2 perfect squares. That's x plus 2 and x minus 2. If you can't factor really well now and relatively easily, these problems are going to start to take you something like 15, 20 minutes of problem. Yeah, it's so bad. That's why you... No, because I assume now that you can factor, and if you can't hang tough with us, you're screwed. If you cannot hang tough with us, got to come in for extra help, or you got to switch. Absolutely. Now we're just going to cross things out, right? Cross out this one. Cross out this one. Oh, look at that. Cross off this one. Cross off this one. Did you not? Did you? Okay, let me go back for a minute. Let me go back for a minute because sometimes that screws up people. Remember I said you got to do top times top, bottom times bottom. So when you do top times top, bottom times bottom, it's like this times this times this. So I might as well just draw the line across and put that in parentheses because that means multiply. Okay? Now, top times top, bottom times bottom. This times this times this. I might as well just put this in parentheses and now it's all being multiplied together without actually don't multiply them. Don't multiply them. Okay? Just cross them off. There we go. And the final answer is simply just 1 over x minus 2. That's it. If you get an answer where there's more than one parentheses, just leave it be. Don't spend your time multiplying. That's all we care about, is your ability to factor and reduce stuff down. Okay, so here's our problem. Here's our problem. I know it looks impossible, right? But you have to factor that. It's like 4 separate factoring problems in one. So that's all we're going to do. We're going to do the next step, we're going to factor. X squared minus 9 is the difference of two perfect squares. It's x plus 3, x minus 3. X squared minus x minus 20, that's going to be x minus 5, x plus 4. Two numbers that multiply to be 20, but add together to be negative 1. Times. Look for the GCF. These guys both have 4x in common. Pull out a 4x. Whatever's left over is going to be x minus 5. And the bottom one, these guys also have 4x in common. And when you pull that out, yeah, 12, 4, x minus 3. Now, I can also give you a little hint with these. If you can factor one of them, it will help give a clue to some of the other ones. Because ultimately, they're going to try and reduce with each other. So don't pick random stuff. It should all cancel away, right? Now, you can draw the line in between, or you can just cross-cancel, as it's called. Find stuff that matches. Ooh, x minus 3, x minus 3. X minus 5, x minus 5, 4x, 4x. Damn. Yeah. The final answer is just x plus 3 over x plus 4. Yeah. So step 1 is just to factor everything. Everything you possibly can. You know, the GCF of 8 and 4k is going to be 4. And after you get done pulling that out, it's going to be like 2 minus k. On the bottom, I mean, the GCF of these is 3. It's k minus 3. This is the difference of two perfect squares. It's k plus 3 and k minus 3. And the bottom, you've got to find two numbers that multiply to be negative 6, but add to be positive 1. Yep. I agree. You were going to try and list out the stuff that does it, but automatically look at the rest of your factors and see if it'll help you isolate which ones probably are the answer. Now, we're going to cancel this and this, and we're going to cancel this and this. Yes, and we're going to talk about something. Just rewrite this part for a second. Okay? So after you get done canceling that stuff off, here's what you get. You have 4. You have 2 minus k. You have 3. And you have k minus 2. See that? Okay. What's your idea? I hear what you're saying, Carly, but moving this number up over here means it's multiplication, but having the number in the front means there are 4 of these being added together, and 3 of these being added together. Here's what I'm saying to you. Do you want the trick right now, or you want me to teach you the shortcut real fast, or you want me to teach you why the shortcut exists? Which one first? Which one first? Why it exists? Why it exists. Here's why it exists. If you see something like this, and it only works with subtraction, if you see something that looks like this, here's what you can do with it, okay? So you're going to get, here's what you have. I'm just going to pull it out so you can see what to do. K minus 2. All I'm going to do is rearrange my deck. Take the top, rotate it. It's negative k plus 2 over k minus 2. Do you see that? All I did was just rotated my deck. I rotated the cards in my hand. I moved the negative k to the front. Okay? Sorry, I need a little bit more room. Now, do you see this top one? This, you can actually pull out a negative 1 from, so that it is k minus 2 over k minus 2. You do not. You do not. A lot of people think this is a lot of extra steps and a lot of work. I agree. But take a look at what happens, right? These two cancel out, and ultimately you're left with negative 1. So when you see 2 things reversed by subtraction like that, you know what they cancel out to be? Negative 1. And you're just left with negative 4 over 3. I mean, it's just a trick. It's just a trick. I don't do this at all every time. It would take forever. Here's the trick, right? 2 minus k over k minus 2 equals negative 1. Okay, anytime you see it. Well, just so you can keep track of stuff and cancel it out. Let's play again with this trick. Let's do it. But yeah. What's that top become? What's the bottom become? Good. Let's play again. Oh, I don't know. What's that become? Becomes negative 1. Yeah, it's just negative 1 over 1, which is negative 1. Now let's play again. What happens if you have this? Yeah, it cancels out. Actually, this one, right? Because you could have just rotated this. How about this? One more, and then we're going to move on. What's that? Yeah, it's the same thing. It doesn't reduce. You can't just reduce stuff down. Okay? Yeah, because you can't. It's just the answer. That's it. Let's do this. This one's a hard one. The top, nothing happens. It's just going to stay like that. The bottom, everything is reversed. Okay? Don't worry about that. We're just going to factor backwards. Okay? The b's have to go over here. Okay? Now give me 2 numbers that multiply to be 12 but add to be 4. Yeah, it's going to be 6, positive 6. Whoops. Sorry about that. No. You know what? We cannot do that. I don't like factoring that way. You know what I'm going to do? This is annoying. This is annoying. Do you see this? Yeah, I don't like it that way. Some people can think that way. Nope. Right? There's that. I'm going to pull out a negative 1. Ah, that's so much better. Oh. Oh. It was too hard to think about it the other way. That's so much better. Oh, it feels so good. What? What happened? What? So we got 6b cubed divided by negative 1, b minus 6, b plus 2, times 4, b plus 2 over 8b. We're going to cancel stuff off. This is going to cancel with this. 4 is going to become a 1, and 8 is going to become a 2. You know, because it's like 4 over 8. One of these b's, this b is going to cancel with one of these b's, and it's going to become a 2. This 2 is going to cancel with itself, and this is going to become a 3. And then finally, is there anything else left? No, there's nothing else left. Hold on, I'll redo it all for you one more time. You get 3b squared divided by negative 1, b minus 6.